1982, the Surface Transportation Assistance Act required the Federal Highway Administration to report to Congress on the benefits and costs of a national intercity truck route network for longer combination vehicles. The California Department of Transportation volunteered to FHWA to conduct an actual over-the-road operational test of 3 longer combination vehicles. This presentation highlights the events of those tests. You will see the longer combination vehicles, which we also refer to as LCVs, traveling on the freeway and negotiating freeway interchanges. You will observe the LCVs in urban traffic, including arterials and intersections. The combination's mobility was tested at rest areas and way stations. Tests were conducted to check the efficiency of the vehicles in sudden braking situations. And off-tracking tests were conducted to check the additional space that these trucks require in turns. We also tested the LCVs for noise generation, fuel economy, acceleration, and movement and mobility on 2-lane roads. The test route covered approximately 1,200 miles of the California street, road, and highway system, stretching from the San Francisco Bay Area down through the San Joaquin Valley and into Los Angeles, then back up into the valley again. Each combination was operated over the same route, allowing observation of operation under a variety of conditions and a comparison between combinations under the same conditions. A request for proposal was sent to numerous trucking companies in the western states, asking for bids to supply tractors and trailers, an experienced driver, and the necessary permits. Viking Freight Systems of Santa Clara, California, was the successful bidder. Ed Bodie, a Viking employee, did all of the driving during the tests. He is one of Viking's line haul drivers assigned out of Sacramento.
We were looking for someone with a whole lot of experience in different types of equipment, primarily some good triples experience, somebody with a good, strong safety record from Pine for many years of driving, someone who would be able to do well under the pressure of the test, obviously the cameras, the escort vehicles, the highway patrol, and someone who's just has a real good attitude and wants to work with, or can work with a different group of people. I can speak for the 11 years with us. He's driven every different type of equipment we've got, and prior to that, he had a pretty good exposure in different types of equipment with other companies. So he's seen and driven almost everything that's on the road, and he's been able to handle it all, very well. His safety record, I think, speaks for that. He's a true professional. He's the kind of driver that we wish every truck driver was.
3 tests were conducted over a period of 3 weeks with the long vehicle combinations. The first being with a combination called the triples. The triples consist of a tractor, a 28-foot semi-trailer, and 2 28-foot trailers, with an overall length of 100.2 feet using a cab-over engine tractor, and a length of 107.4 feet using a 3-axle conventional tractor. The second week of testing was with a Rocky Mountain doubles combination, consisting of a 3-axle conventional tractor pulling a 48-foot semi-trailer and a 28-foot trailer. This combination had an overall length of 93.2 feet. The longest truck combination tested was the Turnpike doubles. It has a 48-foot semi-trailer and a 48-foot trailer and an overall length of 115 feet using a conventional 3-axle tractor. The 28-foot long, 102 inches wide trailers were made available from Viking's fleet. They were equipped with automatic brake slack adjusters, which were designed to keep the brakes adjusted automatically. 6 trailers were provided, allowing for testing of loaded and unloaded combinations. Each loaded trailer remained that way throughout the test to ensure that the weights were always the same. A number of single-axle converter gears were made available from the existing Viking fleet. These were 96-inch width dollies and generally also had the automatic slack adjusters. 2 48-foot by 102-inch trailers were provided by Dowdell Trucking. The sides and nose were constructed with fiberglass reinforced plywood. It was necessary to add a pintle hook and air brake connections, as a 48-foot trailer was not available with these features from the manufacturer. A 96-inch tandem axle dolly was used for the turnpike doubles combination. It required all new tires and all new plumbing and valving to bring it up to the quality of the other equipment. A total of 4 tractors were used during the test. 2 Kenworth K100 cab-over engine 4x2 tractors were made available from the existing Viking fleet. Both have a 120-inch wheelbase. The first one used was 3 years old and had 270,000 miles on it. It is equipped with an automatic transmission with a transmission speed retarder, disc brakes, and is powered by a Detroit diesel that produces 304 horsepower to the ground at 2,000 RPM. The second Kenworth cab-over was very similar to the first, except it was equipped with drum instead of disc brakes. It was used in the brake test to provide comparable data with other brake tests using drum brake factors. The third tractor used was a Ford LTL 9000 6x4 conventional tractor from the existing Viking fleet. It was a 1983 model with 90,000 miles on it. It produces 340 horsepower to the ground at 2,000 RPM. It is equipped with a fuller 10-speed manual transmission. It has a 186-inch wheelbase. The fourth tractor was an almost new Freightliner with only about 9,000 miles on it. This tractor has a 210-inch wheelbase, is powered by a Cummins diesel engine coupled to a 13-speed manual transmission, and produces 480 horsepower to the ground. The California Highway Patrol was an important part of the test team and provided a number of services. The CHP officer is a mobile road enforcement officer trained to perform the critical item inspection for commercial vehicles. Each combination was inspected daily to ensure safe operation. The CHP officer also acted as an escort and provided traffic control services at times. Each combination was loaded as heavily as possible without exceeding the Formula B limits. The 80,000-pound upper limit was not considered. The triples were loaded to 111,000 pounds and were within 100 pounds of the Formula B maximum. The Rocky Mountain doubles were loaded to 106,850 pounds, within 250 pounds of the maximum. The Turnpike doubles were loaded to 122,650 pounds, which was within 2,250 pounds of the maximum. The combinations were loaded in accordance with WHI recommendations. That is, the heaviest trailer was in front, the lightest in the rear, and a balanced load in each trailer. Tests to certify braking distances were conducted on a partially constructed, unopened section of new freeway in the San Jose area. All tests were conducted on the same roadway section and were run both empty and loaded on dry and wet pavement. To simulate wet conditions, the pavement was watered by a construction water truck, applying a full width of spray immediately before the test, which would run the entire length of the braking distance. The combinations tested were the same ones used on the over-the-road tests. The asphalt was 3 to 6 weeks old and had not had traffic on it. The coefficient of friction was measured with a friction analyzer. Each combination ran in the middle of the 37-foot wide pavement. The stopping speed was measured with a radar gun, and radio communication allowed the driver to increase or decrease the approach speed.
55. 55. Looking good. 55.
Each combination was braked at 3 different speeds, 25, 45, and 55 miles per hour. An electromechanical gun is attached to the tractor, which shoots a blank shell when the brake is applied, which allows for the actual stopping distance and not accounting for the driver's reaction time. Only the actual stopping distance was measured from the point of brake application to the actual stopping of the combination. As noted earlier, several tests were conducted over the course of 2 days. The single 48-foot semi was tested along with the 3 primary combinations. A separate film was made of the braking tests, and a written report details the actual speed, pavement condition, and stopping distance of each test. What we wish to do here is show some of the tests. All braking tests were not completed with the turnpike doubles. The load had been bulkheaded to obtain maximum loading. Then, on the first loaded brake test, there was a uniform shifting of pallets, collapsing the bulkhead and breaking through the trailer nose.
Well, the only thing I could have, so we were going 25 miles an hour on a dry brake test, and I applied the brakes, and evidently the bulkhead came loose in the rear trailer here, and the load just shifted forward and went to the nose of the trailer.
Would that happen very often, or just a freak accident?
Well, if the bulkhead's put up properly and stable enough, and most of your loads, you don't really have bulkheads. Your load is all the way to the nose of the trailer, but due to the weight of these books and things like that, we had to keep the load back so you don't overload your axles.
This does indicate that substantial attention should be paid to the actual loading and tie-down procedures. In these tests, the combinations varied from stopping straight to a movement of 5 feet sideways. Movement occurred to both the right and the left, although most variation appeared to the left, in the direction of the pavement cross-slope. Generally, each combination took slightly more distance to stop under wet conditions, but not significantly more. When loaded, each combination took slightly more distance to stop than when empty, but not significantly more. The triples with 2 axles took less distance to stop than the triples being pulled by the 3-axle tractor. The empty long vehicle combinations stopped in generally the same distance as the 48-foot semi-trailer. Acceleration tests were also conducted. Measurements were taken using a radar gun and stopwatch to determine a time versus speed comparison. Off-tracking tests were conducted in the Viking Yard in Santa Clara, California. Off-tracking is defined as the additional width over and above the truck width required by a vehicle when making a turn. A Caltrans survey crew laid out 60, 80, and 100-foot radius curves over a 180-degree central angle on the parking lot surface. Central angle increments of 30 degrees were marked on the curves. Each test combination entered the curve on the tangent. The driver steered the outside edge of the left front tire on the curve, then proceeded to drive around the curve, exiting the curve on the tangent. The single 48-foot semi was tested along with the 3 test combinations. While the combination moved around the curve, the path of the right rearmost tire was continuously marked on the pavement. The distance from the appropriate curve center to the rearmost tire mark was recorded at 30-degree increments, and the difference between this recording and the curve radius was measured as the amount of swept width. The off-tracking was generally at a maximum at around 120 degrees of the central curve. The off-tracking for each combination decreased as the curve radius increased. The off-tracking did increase as the combinations went from 48-foot semi to cab-over triple to conventional triple to Rocky Mountain double to turnpike doubles. These measurements agree with the over-the-road observations made of the different combinations at the same locations. Complete test results are in the written report available from Caltrans. Caltrans offered to conduct the on-the-road operational tests because the state has all the diverse conditions through which long vehicle combinations could potentially operate. The test was intended to show the actual operational characteristics of each combination, and also to show under what conditions the operation might be restricted and why it might be restricted. An advisory committee consisting of the California Highway Patrol, FHWA, and the Western Highway Institute, a nonprofit trade association, provided input to Caltrans in outlining and generally scoping the operational tests. All combinations were tested on generally the same freeway-to-freeway and freeway-to-local interchanges to observe the performance of each and to compare the performances of each. You will see each combination negotiate 3 different interchanges, allowing for a close scrutiny of the problems encountered by each of them. The triples had the fewest problems on the ramps and could maneuver almost as well as existing long semi-trailers, such as those allowed under the STAA. The Rocky Mountain doubles encountered some problems when maneuvering through some interchanges. The turnpike doubles also experienced the same problem. Such actions would result in accelerated deterioration of shoulder edges and increase the chances of striking roadside objects. Based on the ramp movements observed, there is significant difference between each of the combinations. The triple trailers traversed most of the interchanges moderately well. Both the Rocky Mountain doubles and the Turnpike doubles consistently crossed over and climbed the curb on many of the older interchanges on the designated system. It was not unusual for one tire of each rear dual to ride the top of the curb, with the other tire being suspended in the air. This situation would create significant pressure on both the tires and the curbs, creating the potential for very rapid curb deterioration and tire blowout. The Turnpike doubles had significant problems on existing interchanges and would affect substantial pavement edge maintenance or new facilities design standards far exceeding those existing today. This test was conducted to see how the combinations would operate on the open road with only minimal interference from other traffic. The Viking driver was instructed to drive normally. All level open road tests were run at 55 to 60 miles per hour. The operation of the triple trailers over the open road produced some of the more notable results of the test. There were extended periods of constant whip and sway. The sway effect produced a constant 4 to 6 inch total sideways displacement movement of the middle portion of the trailer combination. The trailer combination had a sine wave, or serpentine appearance, with maximum movement occurring between the second and third trailers. There was generally little apparent sideways movement of the rear of the third trailer. The serpentine action was particularly noticeable on I-580 and I-5. This 125-mile stretch of freeway consists of a modern design standard 4-lane freeway in rolling or flat terrain in totally rural areas. There was no noticeable wind, minimal traffic, and no apparent physical deficiencies of the roadway. The loaded trailers were in a constant serpentine movement during the run of this entire segment. There were times when there was no sway movement of the trailers. However, it is estimated that some sway occurred for over 75% of the total mileage of the test. At times, the whip and sway motion approached the 8 to 12 inch sideways motion for extended periods of time. There were also isolated incidents where the sway greatly exceeded 1 foot and approached the 3 to 4 foot range. There was considerable speculation about what could be done to eliminate the problem, with little success, but it was agreed that it was important enough to be investigated thoroughly. The reaction to the loaded Rocky Mountain doubles on the open road can best be described by repeating a radio transmission by the test crew. They look like they are welded together. There was absolutely no whip or sway observed. The Turnpike doubles had the same operating characteristics as the Rocky Mountain doubles. No open road problems were observed with this combination. All three long vehicle combinations were run through significant amounts of urban travel conditions to test the feasibility of operation in these areas. This phase of the test had 4 elements. 1. Operation on urban freeways. 2. Impact on urban ramp traffic entering or leaving the freeway. 3. Operation on urban arterials. 4. Operation in urban arterial intersections. It appears that the viability of the long vehicle combinations on mainline urban freeways depends almost exclusively on the skill of the driver. The length or configuration of the vehicle is not a major factor. The driver took the approach of driving a steady line. That is, an absolute minimum number of lane changes, making the necessary lane changes far in advance, trying to maintain a constant speed, and not rushing through the urban areas. There were a few instances where a vehicle was alongside the test truck and had to brake or accelerate when a lane drop occurred. There seemed to be no real problems encountered in urban freeway traffic, and again, this is felt to be mainly attributable to the skill of the driver. The large combination vehicles encountered little difficulty with other vehicles that were entering or exiting an urban freeway. This was primarily due to the driver driving one lane over from the right lane. This technique is practiced by most trucks in urban areas, regardless of length. There were situations where this technique was not possible. Entering vehicles did not always have an open space into which to merge, requiring either braking, acceleration, or occasionally driving on the shoulder. The amount of interference appeared to be proportional to the vehicle length. The traffic on urban arterials ranged from moderate congestion to stop-and-go traffic. In moderate congestion, the driver had no problems maintaining speed or making the necessary lane changes. This, again, was based on the driver's diligence. As congestion increased, problems for the driver increased. Speeds are slower on arterials, thus the distance between vehicles is less. Arterials also have signals, which create packs of traffic, rather than spreading it out. This gave the driver less of an opportunity to make many movements for the test, although each combination did have more difficulty than shorter trucks or transit buses. The Turnpike doubles, and to some extent the Rocky Mountain doubles, had some difficulty entering and exiting the Viking Yard in Modesto. The facility is on Crow's Landing Road, a 4-lane arterial, with a striped dual left turn lane and a curbed 30-foot wide entrance and exit. On a right turn exit from this yard, the Turnpike double encroached about 4 feet into the dual left turn lane. This required stopping the traffic on Crow's Landing Road so the vehicle could make the turn. It is doubtful that the combination could make this move safely without considerable waiting for a traffic opening. All combinations were tested at generally the same intersections. As with the freeway interchanges, you will see each combination negotiating the same 3 urban intersections. Generally, the triples had the fewest problems at urban intersections, encroaching into the opposing lane about 2 feet. At many intersections, and especially for the Turnpike doubles, left turns were not made from the left turn pockets. The reasons were that the left turn pockets were not long enough for the test vehicle to get into straight. There was usually another vehicle in the pocket, which further reduced the amount of space, and the driver generally needed all the room he had available. Generally, the non-signaled intersections were closed off until the test vehicle had cleared it. While this tactic was not used for maneuverability, it was needed because there was generally not a sufficient gap in traffic from the other directions to allow the vehicle to turn through the intersection. Turnpike doubles required 2 full lanes. This encroachment would usually result in waiting for the truck or the other traffic. The possibility also exists for potential damage to curbs, signs, and signals at intersections, or traffic being caught between the long combination and other fixed objects. On part of each combination's run, lane widths less than 12 feet were encountered. With one exception, the test vehicle did not have any problems staying totally within its lane. The one exception was the second triples run on the 10-foot lanes on the Benicia Bridge in the Bay Area. In this instance, the combination had had the outside tire of the left side duals riding on the lane line for 1/3 to 1/2 of the 1,000-foot section. The triples and the turnpike doubles were tested on a 2-lane section of road, Route 198, between Interstate 5 and Route 99. This route is about 48 miles long. The entire route is essentially straight and level with few at-grade crossings. The turnpike doubles were comfortably passed by other vehicles. Oncoming traffic tended to shy away from the center line, not only for the long combinations, but for any large truck. It was not unusual to see both the test truck and opposing traffic with the right wheels on the shoulder delineation stripe. There was some blowing dust observed when the test truck passed another vehicle, but this was not much different from that observed by any other large truck. The long vehicle combinations were tested at facilities on or adjacent to freeways. These included safety roadside rest areas, truck scales, and truck stops. Each test vehicle stopped at roadside rests along the route. Each roadside rest was of modern design, with parking for autos, trucks, and travel trailers. The truck parking areas have diagonal parking. Except once, the truck used from 3 to 5 truck spaces, as it was parked even more diagonally. This was done to prevent blocking of the entrance and exit driveways. The one exception was the cab-over triple, the first time a rest area was used. It was parked in one designated space and was longer than the parking space, thus blocking the entrance and exit areas. Because of the vehicle length, there would need to be some modification of California's roadside rests if the long combination vehicles were allowed in them. The modifications could range from simply restriping the truck parking areas to new construction of parking areas solely for the longer combinations. All loaded trucks are required to stop at weigh stations, where the procedure is simply to pass over the scales, then continue back onto the freeway. There are no problems. However, occasions will arise when a more detailed inspection, such as an equipment check, would require other maneuvers. In addition, the driver may be forced to loop the weigh station for reweighing. The test trucks had mixed success in performing these additional maneuvers. At times, the additional maneuvers were not even attempted because of the size of the weigh station. None of the combinations fit totally under the inspection sheds, which would require the inspectors to work in adverse weather. Again, any modifications to the weigh stations would be site-specific and would depend upon the volume of long combinations using the scales. Nevertheless, modifications would be necessary, and they would be more substantial than the rest area changes. While truck stops are private facilities, they would probably be used by drivers of the longer combinations. During the test, the long combinations did experience several minor problems, such as finding a suitable parking space. The truck stop owners may have to make special provisions for the longer combinations. Speed measurements were made on 2 grades to test the long combination's hill climbing ability. The measurements were made on I-580 at Altamont Pass. Eastbound is a 4% grade, and westbound is a 3% grade. Measurements were also taken on the Grapevine on I-5. Northbound and southbound are both 6% grades. Radar readings allowed simultaneous checking of a large sample of 5-axle trucks against which the test trucks' speeds could be compared. A summary of these speeds can be obtained in the written report. The slow speed, along with the number of trucks traveling over the Grapevine, produced a potential problem area. Normal operation is when the slower trucks use the far right lane. Then the faster trucks use the lane left of that one to pass, and the autos have the inside 2 lanes for the same maneuvers. But the long combinations were so slow that even the slow conventional trucks had to pass them. When this happened, the faster trucks took one of the lanes usually reserved for the automobiles, leaving the cars with only 1 lane. This condition substantiates the need for a reasonable minimum speed on these grades. The long combinations were also observed going down the 6% grapevine grade. With both the triples and the turnpike doubles, there was considerable smoking of the brakes. However, there was never a loss of brakes. On the triples, this was later discovered to be caused by uneven brake pressure throughout the braking system. The only significant rain occurred from Altamont Pass on I-580, over a distance of about 20 miles. The rain was heavy enough to observe the performance of the long vehicle combinations on the open road in inclement weather. Neither the loaded Rocky Mountain doubles nor the turnpike doubles experienced any handling problems because of the wet pavement. The Rocky Mountain doubles combination was outfitted with spray deflectors on the 28-foot trailer, but none were on the 48-foot trailer. The spray deflectors proved very effective. It was not unusual for an automobile to pass the 28-foot trailer at normal speed, and then hesitate to pass the 48-foot trailer because of the spray generated by the wheels. Although we were prepared to test the effects of wind on the empty combinations, it was not possible because the wind did not exceed 8 miles per hour during each of the 3 test runs. Noise measurements were made during the operation of a loaded triples test. The readings were made at 6 locations of both the test truck and a representative sample of other large trucks. The results of the test indicated that the noise emissions of the triples were not unusually high or low compared to the noise emissions of other trucks. A variety of conclusions can be made when comparing the longer combination vehicles with other existing 5-axle trucks. In some instances, there was little difference, notably in such areas as braking, splash and spray, narrow lanes, 2-lane roads, and noise generation. There were generally some very apparent differences between the long combinations and standard combinations. These differences usually related to the extended lengths and weights of the longer combinations and include mobility on urban freeways and arterials, freeway facilities, and on grades. The extra weight behind tractors designed for legal loads also had a definite effect on the acceleration of the vehicles. We also found that the differences do exist between the 3 combinations tested. That is, there are different handling or maneuverability characteristics for each. The more prominent problem with the triples, which could prevent their universal operation, was the constant whip and sway, which could create problems in dense traffic conditions. The triples, however, proved as maneuverable as the largest combinations legal in California on the designated system. The Rocky Mountain doubles encountered none of the road problems associated with the triples, but they did have a difficult time maneuvering through existing interchanges and intersections. They proved less maneuverable than the largest combinations currently legal in California. This could result in greatly increased pavement edge damage and roadside equipment damage and a hazard to adjacent traffic. The turnpike doubles also proved very stable on the open road, but were even less maneuverable than the Rocky Mountain doubles. They could not successfully negotiate some interchanges within the confines of the roadway. This again would result in pavement and sign damage, even more severe than with the other combinations. The handling and maneuvering problems were even more magnified off the freeways in the urban areas. It is probable that special provisions may be needed for long vehicle combinations, or thought should be given to special operating conditions and limitations. In conclusion, these tests indicated the need for diligent governing procedures with respect to allowing longer combination vehicles on the designated freeway system. The vast majority of the system was designed to accommodate a vehicle now 2 generations old. Further increases in truck combination size must be carefully evaluated with respect to the safety of the motoring public and possible damage to the highway system. It was the intent of these tests to point out the operational characteristics and limitations of the longer combination vehicles in today's traffic conditions.
As far as the triple trailer is concerned, for the interstates, they'd probably be fine, but anywhere else other than on the interstates, with drop-off points along there, I couldn't see them being used. It'd be too much of a traffic hazard, too much congestion. They're hard to handle.
Would you like to see them in California, though, besides going into the city limits?
Yeah, on the interstates, it'd probably help the freight haulers, but as far as I'm concerned, I wouldn't want to pull 3 of these ammonia trailers, no. That's for sure.
They're fine with me on the freeway. When you get on another two-way highway, it's a little different thing, but on the highway, on the freeways, they're fine with me.
Would you like to see them in California? Do you think that it would help our trucking industry at all?
Not that they will save fuel.
What do you think of them on city streets?
Well, city streets are going to have problems, but as far as the freeways and your main highways, there's no problem. Because a setup like that will turn sharp around a corner than this truck will here. The trailers follow better.
Have you got any opinion about running trucks this long on the road today?
Well, yes, really. I think that trucks are getting too long and too much load are detrimental to the highways. And although they do pay their fee and taxes on it, that still doesn't help the highways to keep them in condition. They could be somewhat dangerous, perhaps, as far as passing and things like that.
I think triples are fine if you got a awake driver and he holds the speed limit. I think there's no problem. Main problem would be is in the city, and that's just going around the turns. Otherwise, freeway straight away, and you just go.
Anytime a truck's got a pup on the back of it, I think they're putting a man out of a job. I'm not really that crazy about it.
You think they're pretty safe, though, or?
I've seen them flip in mountain country, slick weather, high winds. They're not safe, no. But normal driving conditions, they're as safe as any other truck.
Having had a day with this, what would be your choice out of the 3?
Out of the 3, it'd be either triples or your Rocky Mountain doubles. As far as to be more movability in more congested areas and things like that.